Welcome back to the Mycoal video. It's currently 3 a.m. I'm bored out of my mind, so I'm making this video. Today, we're going to be breaking down a simple but super important concept in machine learning, which is called one-hot encoding. So basically, one-hot encoding is a method of converting categorical data into a vector format that machine learning models can understand. Let's say you have three classes: cat, dog, and bird. Instead of feeding the model as cat equals 0, dog equals 1, or bird equals 2, we can instead one-hot encode it into vectors, where cat equals 1, 0, 0, dog equals 0, 1, 0, and bird equals 0, 0, 1. Why do we use one-hot encoding instead of just doing the cat equals 0, dog equals 1, bird equals 2? Models can't understand strings like dog or blue, and if we assign numbers like, for example, the cat equals 0, dog equals 1, bird equals 2, it might falsely suggest order of magnitude. For example, the bird being higher than the dog, which is wrong, because in reality they're just all the same classes. Here's a good example. Let's say you're trying to represent the environment of the hit game Stick War or Cartoon Wars, in which you summon units to take out the enemy. To represent each unit on the field, you want to one-hot encode them to their specific unit type. For example, in Stick War, you would do 1, 0, 0 for the Swords Wrath, 0, 1, 0 for Archidon, 0, 0, 1 for Mycoal. And we do this instead of doing something like Mycoal equals 0, Swords Wrath equals 1, and Archidon equals 2. If you do the latter way, we're creating an ordering, which we're meant not to do. To machine learning model, it looks like the Archidon is better than the Mycoal and the Swords Wrath, even though they have their own different use cases. So it's going to think that the categories are on a numeric scale, like bad, okay, and good. In reality, they're just labels. If we want to encode it into this basic binary vectors with 1s and 0s, there's no implied order, and the model can learn each category independently, and there's no false relationship between the Swords Wrath, the Archidon, and the Mycoal. Also, now in the background footage, you can see my use of one-hot encoding. For example, I use one-hot encoding to tell the model who they're fighting against. So for example, the Swords Wrath would be 1, 0, 0, 0, 0, 0, 0, 0. I use this many zeros because it allows me to add in as many characters as I want, or until I use up all the zeros. For example, in this next clip here, I have the Archidon, in which its values are 0, 1, 0, 0, 0, 0. By using one-hot encoding here, I was able to tell the model that instead of fighting as a Swords Wrath, you're now fighting as an Archidon, and vice versa. This allows me to keep training the same model over and over again, so that way I don't have to restart or create a new model every single time, with each one training as a different type of person and against a different type of unit. Finally, when shouldn't we use one-hot encoding in reinforcement learning? If my state is already a vector, for example, as a position or velocity, we could just normalize it and feed it inside as one input. However, because one-hot encoding takes up so many input neurons, if the state and action space is massive, for example like 10,000 plus, then one-hot encoding becomes really huge and really sparse. In these cases, we could just use embedding instead. Thank you for watching, and I hope this video helped you understand one-hot encoding in reinforcement learning.